Okay, so visually, kind of go through that process with us. We're still looking at 6 going into 726, but we're going to look at it in terms of blocks. So first we want to make a picture of what 726 looks like. And then from there we want to determine how many hundreds. So that's what's going on here, is they, was able to go in there 600 times. Was able to go in there once. And then we want to look at, so here's the 600 again. So then how many groups of 10 were there? So it went in there twice. So this is 120, but it went in there 2 times. So once in there, 2 for that. And then that left us with the other 6. So 600, 120, and then we have that group of 6 there that it went in there once. So it goes in the hundreds once, twice, in groups of 10, and then once. So we still get 121. But this lets us see that how we're grouping that, noticing that we're creating 6 equal sets, 6 equal groups. Associating that division is about setting up equal groups each time. Okay, so the area model is, again, another concrete way to kind of visualize what this division process is. So we're still going to look at 6 into 726 here. But what the area model says is, let's say I've got a box of area length 726, and I've got one side length of 6. What would the other side length be? Okay, and that's, we're trying to find the missing number. So how many hundreds would go in there? How many tens would go in there? And how many ones would go in there? So we'd be literally splitting this up into, sorry, let me get some more space here. Scroll down. Okay, so from here we would say, well, I know I can get 600 out of that. So there's 100 there. I know I can get 120 out of that. So there's another 20. And I know I can get 6 out of that. So it's just a different way to sort of visually break that up. And notice we add up all the numbers, we still get 121. But now I can see how each of those, how 726 is broken up differently to get those different regions. Okay, short division. Let me give us a problem that we can work on. So 5 divided into 2,880. So short division is a nice sort of shorthand, I guess. We're not writing out the full division algorithm. We're sort of keeping track of remainders. So we'd start with how much does 5 doesn't go into 2, 5 does go into 28. 5 times, so 5 times 5 is 25, so it's got a remainder of 3. And then I'd look at the 38, and I'd ask myself, how much does 5 go into 38? And 38, closest one is 35, so it goes in there 7 times. And 38 minus 35 is 3 again, so a remainder of 3. And then I look at the 30, how much does 5 go into 30? And that'd be 6 times. So it's sort of a shorthand version of the normal division algorithm, but allows us to just focus in on the remainders each time, as far as how many times does it go in with the new set of number. Okay, so let's take a second and explore how to do multiplication in different bases. Let's go back to our base 5 friend for a moment. And let's actually construct a multiplication table of what that would look like if I just multiply every possible number together. What would happen? Well, let's start with this row of zeros. Obviously 0 times anything is 0, so that's pretty boring. So going down there we got zeros. times 1 doesn't change anything. So same thing there. Okay, so here's where it gets interesting. Our next number is 2 times 2, which is 4. Then we have 3 times 2, which is 6. Okay, so in base 5, I don't have a 6 anymore because I've already jumped over to another place value. And if you remember in base 5, we go 1, 2, 3, 4. And instead of writing 5 and 6, we write, let's see, 5 would be 1, 0, and this would be 1, 1. 7 would be 1, 2. Okay, so anyways, going back over here. So we got 2 times 3, which is 6, so that's 1, 1. And 3 times 2, let's see, 2 times 3 is 6, so 1, 1 there. Alright, then we have, add some rows here so in case this is getting sloppy and hard to read. We can see it a little bit easier, at least that's the intention. Okay, so that brings us to 4 times 2, which is 8. So 8 has at least one 5 in it, and 3 more to go. So 2, so if you think about 8, sorry, here, let's just write it out there. So 8 was 1, 3. There we go, that wasn't too hard. 2 times 4 is 1, 3 again. And these aren't 13s, these are 1, 3s. We're signifying place value. 3 times 3 is 9. So 9 is 1, 4. Let's see, then we have what? 4 times 3 is 12. Okay, so 12, let's see if I can carry my chart here. 10 would be 2, 0. 11 would be 2, 1. 12 would be 2, 2. So 2, 2 for the 12, and that's 4 times 3, so that's 12 there. And then 4 times 4 is 16. Sorry, so let's see, 1, 3, 1, 4, 1, 5, and 1, 6. So 2, 3, 2, 4. Then we switch to another place value, 3, 0, 3, 1. So 16, what we consider to be 16 would be 3, 1. Okay, now, so we're going to refer back to this chart as far as whenever we're trying to multiply out. Okay, so let's now that we've generated that chart, let's actually look at it an example of this, and then we'll talk about how that chart helps us. Okay, so let's take 23 or 2, 3 in base 5 and 1, 4 in base 5, and let's multiply those together. Okay, so what we're going to do is we're going to look at the 4 different multiplications we've got going here. We've got the 4 times the 3 and the 4 times the 2. So that translates to 4 times 3 in base 5 and 4 times the 2, 0 in base 5. And then we have the 10 times the 3 and the 10 times the 20. So 10 times 3 in base 5 and 10 times the 20. Okay, so go back to your chart. When you look at 4 times 3, what number is that? That's the 2, 2. Okay, what about 4 times 20? 4 times 20, well, we would consider that to be an 8, but look at your chart. Where do you see an 8? That's where there's a 1, 3, and then we have that place value that we can throw in there. 10 times 3 is 30, so that's a 3 with a place value. So 3 with, a 0 at the end. And then 10 times 20 is 200, and that's a 2 with 2 place values at the end. Okay, so then again, keep in mind these are all in base 5, but we'll add this up. So obviously 2 and a bunch of zeros is 2. Here we get 3 plus 3 is 8. Okay, but in base 5 we don't have an 8, but we do have, let's see, the 1, 3. So I take a 3 there and I add another place value of 1, and so that gives us 4. Okay, so the product would be 432 in terms of base 5.